Okay, so today we're just continuing off exactly where we left off yesterday. Yesterday we were talking about the physical properties of matter, so how it looks and what it's made of. Today we're going to talk about the chemical properties of matter. So just like with physical properties of matter, matter can be classified by their chemical properties. These describe how a substance interacts with other substances. So a chemical property has nothing to do with what it looks like or any intrinsic value with it. It has to do with how it behaves with other things. Okay, moving on here. Some of the ways we can test the chemical properties of matter are including these 5 different things. First of all, reaction with acids. I want you to think of baking soda's reaction with vinegar. Vinegar, of course, is an acid. When you mix baking soda and vinegar, it makes like that volcano experiment kind of thing, right? So there's quite a considerable reaction that happens with that. That would be an example of a chemical property of both the baking soda and of the vinegar. It reacts with these other things. Another chemical property is the ability to burn. A question you may have asked yourself, or maybe you've never asked yourself this, I don't know, I'm not going to judge your life, is why do some things burn and other things melt, right? So if you put certain things in the oven, it'll melt, but if you put other things in the oven, it'll burn. Why does it do that? The ability to burn is a chemical property. The reaction with water, what I mean by that is, does it dissolve? Does it rust? Does it explode? Water can do different things to different kinds of chemicals, right? Those are all chemical properties of all these different things. Behavior in air, things like silver, of course, tarnishes if you just leave it out in air long enough, like that silver spoon you see in the bottom left-hand corner. So again, things can tarnish just by being left out in the air. And then lastly, reaction to heat. Some things, when you heat them up or cool them down, there's a color change. That could be actually a chemical property. Sometimes it's a physical property, though, like if you heat up metal and then it glows red, that would be more it's starting to turn into a liquid, which is a physical property. But again, reaction to heat can be another thing that is a chemical property. So physical versus chemical changes. A physical change of matter is where the material changes from one state to another. This is quite easily reversible, right? So when you heat something up like a solid and then it turns into a liquid, that of course is a physical change because it's just changing from a solid to a liquid. A chemical change, however, though, is that occurs when two or more materials react and it creates brand new materials. Now, the best way of thinking about a chemical change is that these are not always reversible. As a matter of fact, usually they aren't reversible. And if they are reversible, it is not easy to reverse them, at least not as easy as it would be to undo a physical change where you can just heat it up or cool it down. The new materials often have different properties than the original materials. A classic example of this would be the combination of, hold on, I'll write it down, the combination of hydrogen gas, which is H2, and oxygen gas, which is O2. If you mix hydrogen gas and oxygen gas, you actually will create H2O, which is, of course, water. Now, the reason that this is interesting in terms of different properties is hydrogen gas and oxygen gas are both extremely flammable. They will burn very, very easily. But H2O, water, obviously does not burn very easily. As a matter of fact, we use it to put out fires. So again, with a chemical change, the products often have totally different properties than the original materials altogether. So there's some evidence of a chemical change. These are not proof of a chemical change, but these are just things that you can use to give evidence that a chemical change may have occurred. The first one is a change in color. Again, that definitely does not prove anything, but it is a little piece of evidence that could help point you towards a chemical change. A change in odor, that's a really big one. If you notice certain things like fruits, especially like bananas, they get a totally different smell after they've like aged a bit. That's because there's chemical changes going on inside those, right? So that change in odor is due to a chemical reaction, a chemical change actually occurring. A formation of a solid or a gas, that is also a really good example of a chemical change. Of course, this is different than if you just heated something up or cooled it down. And just an FYI, a solid forming inside of a liquid, like if you mix two things together and then a solid forms inside the liquid, we call that a precipitate. I don't think you'll know that right or need to know that right away, but that is an important vocab term that comes around, certainly in future science courses. Lastly, a release or absorption of heat energy. If you ever buy like those hot packs where you're like, you enable them and all of a sudden it gets really warm, or even a cold pack where you like snap it and then it gets really cold. That's because what you're doing is when you snap those packs, it's mixing two chemicals together, which is causing a chemical reaction, which is either releasing heat or absorbing heat. Okay, so again, that would be another indication of a chemical change. Now, even still, it may be difficult to determine whether a chemical change has occurred. Further chemical analysis may be needed than just these observations. But again, these observations here are at very least a really good starting point. So we're going to do a little activity here. I want you to watch this, and I'll give some time. You won't have to pause anything here. Basically, the next few slides, I want you to identify if this is a physical or a chemical change. So we're going to start with this very first one. If you put a pot of water on the stove and you let it boil like you see in this, this video here, is that a physical change or is that a chemical change? Think about that one. Well, if you shouted at your screen right now, physical change, you're absolutely right. It is a physical change. All it's doing is the water is turning from a liquid into a gas, right? So there's water vapor coming off of this. It's invisible. We can't see it. I mean, steam can kind of be seen a little bit. But again, all you're doing is you're just changing it from one form to another. It is not changing what it is. So there's nothing new being produced. It's just changing from a liquid into a gas form. Oh, if it's going to let me move on. There we go. Okay, what about this one? Physical or a chemical change? Lighting a match. So you struck a match against the matchbox and it lit on fire. Is that a physical change or is that a chemical change? Okay, so if you shouted chemical change, you are correct. It is a chemical change because something totally brand new is being created. You're turning a wooden match with a little bit of, I think it's a form of sulfur on the tip, into like basically a piece of charcoal, which is mostly just carbon, right? So there's actually a chemical change occurring within this. And of course, carbon dioxide gas is being released and all this other stuff. So yeah, there totally is a chemical reaction occurring here. This is different than just heating something up. When you're lighting something on fire, that is actually a chemical reaction that's happening, at very least between the object that's burning and the oxygen that is fueling that fire. All right, this one's really neat. Is this a physical or a chemical change? Lighting mercury 2-thiocyanate, also known as Pharaoh's snake. And it just keeps on going. So what do you think? If we're lighting that with a little bit of fire and then it performs this crazy stunt right here, is that a physical change or a chemical change? Well, hopefully you've screamed at your screen right now that this is a chemical change, because it totally is a chemical change. There is something turning into something totally different. This is not just changing from one form to another. It is totally creating something new here through a chemical reaction. Another way of thinking about chemical changes is it's not very easily reversible. If I asked you, okay, now take this big like lump of whatever you want to call it, the Pharaoh's snake here, the brown mush stuff, and I want you to turn it back into that white powder that it was in the first place, you wouldn't be able to do that so easy. I don't even know if you'd be able to do it at all. So in other words, this is not a reversible situation, so it definitely is a chemical change. What about this? Baking a loaf of bread. That's not a loaf of bread right there. That's a bread dog, not a loaf of bread. But let's pretend it is a loaf of bread here. I don't know why I threw it in like this. I think I thought it was funny like a year ago or something. But anyway, if you're baking a loaf of bread, would that be a physical change or would that be a chemical change? Well, I'm going to spoil it for you here. It is actually a chemical change. When you are baking something, it is actually changing the chemical composition of the thing you're baking. It isn't just warming it up. It is actually changing it chemically from one thing to something else, right? So a raw mush of bread dough is not the same thing as a baked loaf of bread. There is a chemical reaction that occurs while it's in the oven, which produces something a little bit new, right? So it's a chemical change. Also, again, you could always use that old analogy. How do you uncook a loaf of bread, right? Like you get your loaf of bread and you're like, oh, you know, I want to reverse this. Let's bring it back to bread dough. Not going to happen, right? So that really is a good indication that it's a chemical change. Some chemical changes are reversible, but if it's not reversible, you can pretty much guarantee that it is a chemical change, not a physical change. Oops, too far. Last one here, mixing water and drink mix. So you're just mixing Kool-Aid and water. Is that going to be a physical change or a chemical change? Well, believe it or not, on this one, this is actually a physical change. Now you might be thinking, whoa, 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 Scott, you said it only like changes from like a solid to a liquid to a gas or whatever. That's all the physical changes. Well, there's actually a couple other states of matter other than solids, liquids, and gases, right? So we have solids, liquids, gases. There's two other states of matter. One of them is only a true state of matter. The other one's not really a state of matter, but more of a state of being. Another state of matter is something called a plasma. Plasma is like basically a gas that's been given an absolute metric ton of energy into it. We won't need to worry about that, but there is another so-called state of matter. I don't even really like calling it a state of matter, but another state that things can be in. It's called aqueous. Aqueous is just a fancy word for dissolved in water, right? So when you take Kool-Aid mix, which is basically just sugar, and you mix it with water, it's actually dissolving and it's forming what we called yesterday a homogeneous solution, right? So it is actually just physically changing it. It is not producing something totally new. And if you don't believe me, you could very easily reverse this just by heating the Kool-Aid drink mix, and then eventually all the water would boil away, which is a physical change in itself. It's just the water becoming a gas, and you'd be left with your Kool-Aid crystal powder once again. It would probably be more like a lump of it, and it would have all been stuck together, but still you'll get your Kool-Aid powder back, right? Anyway, moving on. Oh, that's it. Wow, we're done already. That wasn't even 12 minutes long. So for practice today, I've got a lot of questions on here, but I really just want you to do page 104, questions 1 to 9 for now. We'll worry about this other set of questions a little bit later. These ones I believe are just on physical properties. And these ones I believe are on chemical properties. I could be mistaken. I could be totally off on this. I don't have a textbook with me here at home. However, I just want you to do page 104, questions 1 to 9, regardless of whether they're just physical or physical and chemical or whatever. No big deal. Anyway, if you guys need me, I am in the Zoom. Best of luck.